Hi and welcome. Thank you for spending the next 30 or so minutes with us. My name is Valerie DiMartino and I'm joined today by Dave Spence. We're here to help you better understand the opportunity of network automation using network intent to ensure critical links are configured properly for failover to prevent outages. First, why should you care? Simply putting a backup or disaster recovery plan in place is no longer enough. Let's face it, if it can fail, it will, probably when you're least expecting it. And the main reason is because configurations change and sometimes drift away from the architect's original design intentions. This is due in part to the manual nature of network operations work. In fact, Gartner states that approximately 70% of network configuration activities, like changes and the associated pre- and post-change activities, are manually driven. This leads to configuration drift, as many manual changes are unplanned and undocumented and often aren't cleaned up after the fact. In the real world, a simple link failure can quickly result in a catastrophic outage. This is due to the drift from the original network design causing problems with the expected failover protection. If someone hasn't properly configured the backup link, it can prevent communication altogether or perform far outside the needs of the critical link design. The backup link is your last line of defense from a blackout, so it must be functional even when not in use. Gartner states that technical entropy, specifically configuration drift, is the primary contributor to networking technical debt. Take, for example, when branch routers were first deployed, each device had an average of 200 configuration lines. Over time, as network teams have added features and changed the quality of service and security policies, there are now more than 450 configuration lines per device. This is due to troubleshooting and layering new applications and requirements onto the network. What could go wrong? Therefore, they predict that by the end of 2025, 30% of enterprises will establish new roles focused on IT resilience and boost end-to-end reliability, tolerability, and recovery by at least 45%. But what's interesting is we're talking about day 2 network operations here. You know, that big chunk of time that happens after you provision and configure the network. We truly feel that this is the area where we can help NetOps better align with the business needs. By establishing every network as a series of network intents, we can eliminate the device level details from the operational staff. And since this level of abstraction exists, human error and errant changes can be eliminated since the operators and engineers are focused on the network intents, not the devices themselves. Network intents manage expected results rather than relying on traditional device level management approaches. Network intent is the intent of your live network in addition to the associated diagnosis logic to detect deviation of those intents. So managing the network as a collection of tens of thousands of intents, not 1,000 devices, is the path to network automation. By abstracting the underlying network details, you can translate business intents to network intents, and then ultimately to device configurations. By combining network intents with automation, day 2 network operations become scalable, a huge value in the era of constrained skilled resource availability. Day 2 automated network operations allows you to manage your hybrid network by capturing, verifying, and enforcing network design intents, and eases problem diagnosis to ensure those conditions are maintained. NetBrain differs drastically from all other device-based network management approaches by focusing on application needs and services in use. NetBrain's problem diagnosis automation system manages hybrid networks as a compilation of network intents, which directly supports IT service delivery needs. We can accelerate the remediation of more than 95% of all network service tickets and eliminate up to 50% of network problems before they impact the production network and the business it supports. This reduces MTTR dramatically, increases uptime, and lowers operational costs. And NetBrain's automation library offers more than 50 intents for modern enterprise network operations. After spending a lot of time talking to our customers, we've learned what their top 8 network challenges are for day 2 network automation. So we've created a webinar series to focus on these use cases. Today's webinar is focused on how intent-based network automation helps prevent network outages due to backup link misconfigurations. The intents do the work for you so you can focus on more important work. They help you troubleshoot ISP infrastructure and MPLS backbones by monitoring, auditing, and checking resiliency before something happens. You can see if a standby link is missing a line of configuration. And we constantly validate the design and report back regularly, which Dave is going to demonstrate. You can verify the health of a link and the state of a critical application path, including a logical check with multiple subchecks for CPU, memory, latency, and BGP prefix changes as an intent. That means check that the second link is up. Does it match the active link's configuration? Is the second hop reachable? NetBrain uses probes to prevent outages and leverages your in-place network monitoring tools to trigger network intents automatically, like to see if there's an interface error. And it can verify compliance by checking the routing protocols are authenticated, and if your access lists are consistent, and that they match certain standards. Modern networks are designed to eliminate critical link failures. The problem is that you rarely test redundancy and failover processes live in production to assure that they will function as needed in stress conditions. Many times a catastrophic failure is the first time that you realize the failover links are misconfigured. Few operations best practices include ongoing verification of standby components. You just assume that resiliency capabilities will function as intended. The intents do the work for you so you can focus on more important work. They help you troubleshoot ISP infrastructure and MPLS backbones by monitoring, auditing, and checking resiliency before something happens. You can see if a standby link is missing a line of configuration. And we constantly validate the design and report back regularly, which Dave is going to demonstrate. You can verify the health of the link and the state of a critical application path, including a logical check with multiple subchecks for CPU, memory, latency, and BGP prefix changes as an intent. That means check that the second link is up. Does it match the active link's configuration? Is the second hop reachable? NetBrain uses probes to prevent outages and leverages your in-place network monitoring tools to trigger network intents automatically, like to see if there's an interface error. And it can verify compliance by checking the routing protocols are authenticated, and if your access lists are consistent, and that they match certain standards. This means you can more easily maintain compliance, improve resiliency, reduce downtime, reduce or eliminate configuration drift, and eliminate manual errors. NetBrain prevents configuration drift from sabotaging your business continuity plan by capturing network intent embedded inside your current failover design, monitoring the design intents continuously, and warning you when detecting configuration drifts so you can deal with them long before users begin reporting service issues or more severe consequences materialize. In a minute, Dave's going to walk through these 4 use cases. He's going to show you how easy it is with NetBrain to ensure simple link failovers don't turn into catastrophic outages due to a drift in the network design that has damaged previously implemented failover protection. In the demo, you'll see how NetBrain uses intent to capture the failover design, monitor the design continuously, and warn you if there's any configuration drift. NetBrain prevents configuration drift from sabotaging your business continuity plan by capturing network intent embedded inside your current failover design, monitoring the design intents continuously, and warning you when detecting configuration drifts so you can deal with them long before users begin reporting service issues or more severe consequences materialize. In a minute, Dave's going to walk through these 4 use cases. He's going to show you how easy it is with NetBrain to ensure simple link failovers don't turn into catastrophic outages due to a drift in the network design that has damaged previously implemented failover protection. In the demo, you'll see how NetBrain uses intent to capture the failover design, monitor the design continuously, and warn if there is any configuration drift. Let's go to our demo. Dave, over to you.
Thanks, Valerie. I'm Dave Spence, Senior Pre-Sales Engineer at NetBrain, and I'm going to be taking you through a demonstration of network intent and how it can help you prevent costly network outages. So in this use case, we're going to look at how NetBrain can protect resiliency. So having redundant links is an important way to protect against network outages. But you also need to ensure that any failover is successful. So are my ACLs consistent? Are my routing tables what I expect them to be? Is the other side of the WAN over here, is that reachable? So it's no good having redundant links if one of them isn't working. So NetBrain's network intent uses automation to verify that everything is working as intended, hence the name, and that if there is a failover, it will be successful. So in this way, we can prevent an outage from occurring and we can keep our network up. That's the idea. And if we look over here on the left, I've got 3 network intents. And we could run these on demand, we could run them on a scheduled basis, or in fact they could be triggered on the response of a particular event. And I'm going to go through that last scenario later on in the demo. So let's have a look at one of these now, and I'll show you how easy it is to create an intent and also have a look at some of the components which make it up. So what we can see here is that a network intent is comprised of member devices and a series of diagnostics which we can run against them. And we can see here that we're performing a couple of tests against each of these devices here. Yeah. So let's have a look at the first one. So we can see here that we're performing a ping on the device to the IP address at the end of the link. But the really clever bit is over here. So we can see here how NetBrain is extracting the output of this command and placing it in a variable. In this case here, it's an integer variable which we're going to call ping. Perhaps I should have called it percent. I wrote this, maybe I should have called it percentage, because that's actually what it is. It's the percentage of replies. So 100% means I've got all 5 ping responses back. But the key thing I want to draw out of this is that we don't have to resort to regular expressions or coding. We're just highlighting where in the output the variable we want resides, and we can see the results below as well. So this is quite a clever way of extracting information, which we would call a visual parser. Now, we can get quite sophisticated here. So we can extract the outputs for paragraphs. So if you think about commands like show interfaces, yeah, you end up with a paragraph for each interface, which is basically the same. It's the same pattern. You've got the same variables, but they're on a per interface basis. Also, we can extract information from tables. So again, easy example, the show IP interface brief command. That's a table format, and we could use something like that to extract information from those type of commands. Now, if we have a look at the next tab over here, yeah, we can have a look at the diagnostic logic which has been applied. So as you can see, it's not really rocket science here. So actually what we're doing here is we're taking the results of the ping command, yeah, that percentage there. And if we have 0 replies, then we've got a problem. We haven't had any replies, which means the link's down. Yeah. So we set a red status code for the device and also for the network intent as a whole. But if the value is anything other than 0, which means we have received replies, then we set the status to green. And And in both cases, the alert has a message which is indicating the result, actually with some variables, giving us a bit more useful information here. Let's go back actually and have a look at one of the other diagnoses. So this is a second diagnostic where we're checking the routing table. So again, we are extracting the result of a CLI command. So in this case, show IP route 10.8.77.0. But this time, what we're doing is we're checking whether there is a valid next hop for the router. So in other words, we are just verifying that the route exists in the routing table. So we can see how we can add multiple tests into a single NI. And in fact, if we look here, we can see, let me just get rid of this, that there are 3 intents, and we can actually do all of this, all of the tests which are in all 3 of these in a single network intent if we really wanted to. I've just split it up because it's easier to see the individual results, and it's better, to be perfectly honest, for a demo purpose. So we've got these 3 individual network intents. So let's have a look at these. So the top one, ACL consistency check. Are my ACLs on the routers on each link consistent? If you think about it, if they weren't, you might end up with subnets or customers which aren't reachable anymore once there's a failover. Next hop check. Are the next hops on each link stable? So this could indicate a routing problem further downstream if they've changed. And finally, we've got the reachability track, and we've just had a look at that. So is the end of the link at the other end of the link reachable? So we need to have confidence in all of these to ensure that we still have network continuity if there is a failover. So what I'm going to do is I'm going to go ahead now. I'm going to run these. Running these network intents is pretty straightforward actually. All you need to do is you need to go and highlight the network intent and then click the big run button here. So I'm doing that in each one in turn. And let's have them all run. So they're all run now. You can see this is good. The last one, the status code was green. And you can go in and very easily and very quickly check and see. And actually, immediately, we've got a problem here. So let's go in and have a look and see what we've got. So we can go in here and actually, you can see this has happened on both ends. So both here and I think this is Canada. And over here, this is supposed to be San Francisco. So I can go into one of the routers over here and we can see the results. So what we can see here is we can see that the intent has failed, but better than that, it's showing us here why it's failed. So we can quite clearly see over here that the access lists on R1 are not the same as the access lists on R2. So immediately we can see that we've got a problem. And when you think about this, this is bad, yeah? The subnets for R1 are definitely not the same as the subnets for R2 in the access list. So this means that if we have a failover, we could be in real trouble. So perhaps some users or applications will no longer be available. So this is incredibly useful because it's alerting us to a potential problem. It's not a problem now, but it's a potential problem for the future. Now, let's have a quick look at the other 2 network intents that we have over here. So again, let's just close this. Let's have a quick look at next hop. So if we look here and the next hop check, everything looks good. If we click at the details over here, look, we can see next hop. This is the particular value, so it's there. It's present. It's not empty. And also here, it's consistent with the baseline. So that's great. The next hop hasn't changed. It's in the routing table and it's consistent with the baseline. So that's all good. Green is good. We can also, let's have a look at the reachability check down here as well. So if we go down here and we go into the network intent and look at the results. Here, look, we've got 2. So we've got the results of the ping reachability test here. And again, we can go in here and we can see, look, ping value equals 100. And again, you can see that here because you've got the text output as well. So we can see here that we received all of the ping replies, so that's great. So look, success. 10.8.77.138 is reachable. Brilliant. And if I go down here, look, and I actually have a look at the other test that I'm performing here, and we can look at the route table test. Here again, this is the text, the actual output, what's happening. So NetBrain is saying to the router, issue the command show IP route 10.8.77.0, extract the next hop, and just verify for this particular test, is it empty or not? If it's not empty, that means that there's an entry for the route in the routing table, and so the other end is reachable. So that's great. Yeah. So this is great. We very quickly verified 3 things here. Yeah. Are the ACLs consistent on the 2 routers? No, they're not. That's bad, but at least we know about that and we can fix it. Do we have consistent routes across the link? Yes, we do. And is the other side of the link, or links in this case, are they reachable? And again, the answer is yes. So as Meatloaf would have said, 2 out of 3 ain't bad, but at least we know before there's a failover, as we have potentially avoided or prevented, and I'll come back to that phrase later, we've prevented an outage. Now, what we've done here is great, but when you think about it, it was all a little bit manual. So wouldn't it be fantastic if this could be triggered by an event? So perhaps we knew the configurations were fine to begin with, but the reason that the ACLs don't match now is due to configuration drift. So perhaps some engineer came along and he's modified the ACLs, perhaps due to a ticket or something else. So wouldn't it be nice if we could automatically check for these issues when an event such as a config change or perhaps an interface status change occurs? Well, thankfully we can. Using NetBrain's Preventative Automation Manager. Let's go over here. Okay, so here we can see our network probes. So think of a probe as a mini network intent. So let's have a look at one of these. There's a good one here that my colleague Leslie's created here. So we can see here that we're using a show IP route command, which is checking for a particular route. And if you go in here, actually, input variable, you can see the actual route that it's checking for. And actually, when you think about this, what we're looking at here, this is very, very similar to what we were doing earlier with our network intent. Now, what we are looking for here is the next hop for a particular route. And if this next hop isn't what we are expecting, then we can trigger an alert. Now, we can also look for, say, configuration changes, which is a bit simpler. Yeah. So here we're checking, has the configuration changed? And if it has, then we can generate an alert. And for any of these, actually, we can select different frequencies. So again, this is running hourly, but I could change that. I could make it run daily. And for some of these, you can really get them running quite frequently. I think that the smallest is about every 5 minutes for these. But the really useful thing here is that these can be used to trigger a network intent, and they can also be used at the same time to send an email. But let's have a look at the trigger here. In fact, I'm going to go over to my configuration check up here. So you can see here, hopefully this should be fairly familiar. So you can see here, this configuration check flash probe is triggering our good old friend, the ACL consistency check network intent. And actually, if there is a problem, if there's a configuration change, it will automatically trigger the ACL consistency check network intent, and that will then send an email because again, if you look at this, it's configured to send an email. Yeah, configuration change, send email, and so is the network intent as well. And in fact, let me see if I can find one. Yes, I've got one over here. So if we look here, this is an example of the type of email you get. So this is one for the configuration change. You can see here, probe name and also the flash alert. But better than that, I've also got over here another email. So this is the one I received after the network intent was triggered as a result of this. So actually, network intent, ACL consistency check. So it's telling me what the network intent is, but it's also saying this is the status. And I've got here ACL of this particular router here, R1, mismatches with the other device. So this is magic. If you think about this, a lot of the time, network outages are as the results of things like this. Somebody's changed something, or perhaps something dynamic in the network, like a routing protocol has changed something. And by the way, those types of issues, they're really hard to spot manually. But nonetheless, the change might have no immediate effect at all. All is fine. Our network appears to be working well, but then something like a failover occurs and we're in big trouble. So by checking for events like this, and then also going ahead, running an intent and digging a bit deeper, we can hopefully prevent a potential outage from ever occurring in the first place. And this is why we call it preventative automation, because it's looking for these hidden, these hard to spot issues, which could have potentially devastating consequences for the future. So what I want to do now very, very quickly is I want also to have a look about what are the implications here for things like public cloud? Because if you think about what we've been talking about so far, everything we've spoken about is concerned with traditional networking equipment, my switches, my routers, my firewalls. But what about the cloud? How can we ensure that we are, say, accessing our cloud resources by the optimal path? Are we going via MPLS or are we going via the internet? Now, if you look at our map here, we can see that we have a traditional data center over here and some networks over here in the public cloud. So over here, look, we've got, if I just pull this down, you've got Google Cloud over here, I've got Azure here, and down here I've got our old friend AWS. Now, what's really key here is that if we have resources in the public cloud, and perhaps these resources are being consumed from a traditional data center, but we need to be able to troubleshoot them if there's a problem. So even from a very simplistic viewpoint, we at least need to know how the traffic is getting there. So what we can see here are a couple of NetBrain A to B paths. So we can see that the green path, this one here, look, this is going via our MPLS network. And we can see here it's going through a Fortinet firewall, through the MPLS network, and then reaching a DX router. However, for the other path, this blue path over here, we're going through this router over here, and then reaching AWS through an internet VPN. If we zoom in a little bit, I can show you a bit more details. You can see this over here. You can see the VPN tunnel. And also, if you look here, you should be able to see as well, here's my VPN, my VPN tunnel. And again, what's great about this, it's showing me here, look, it's showing me information like VRFs. And this is what we call these dynamic maps, by the way, because as we zoom in, we get more information. And this is incredibly useful because if you're a company and you're hosting applications in the cloud, and they're probably being consumed within their own organization, or perhaps they're being consumed over the internet. So they really need to know how these applications flow over these various different networks and then back into the building. And we can see all of that very easily here. And it's very visual, very, very visual indeed. So I think I've pretty much done everything or said everything I wanted to say. So we've looked in quite a bit of depth, really, at how NetBrain can check our WAN links and ensure that if there is a failover, there won't be any nasty surprises lurking for us. And we've also looked at how NetBrain can prevent outages by automatically triggering these checks in response to something like a network change occurring. And finally, we've shown how, when using the public cloud, NetBrain can visualize the exact path between our on-premise equipment and our public cloud resources. So, thanks for listening. I'll hand you back to Valerie.
Thank you, Dave. Great demo. Please find lots of great resources on our site and how you can get started on your own or talk to one of our experts. Everyone, thank you so much for your time today. Now we have some time for Q&A.
Hey, great. Thank you so much, everyone, for joining us. We do have a few questions here, Dave. First one is, where does this fit in my monitoring solution like PRTG? Does it replace it or complement it?
That's a really good question. Now, yeah, it's a, let me just think about that. So if you think about this, your monitoring solution, maybe the best analogy here is think of your monitoring solution as a, think of it in your kitchen. You've got a smoke detector, yeah? So think of your monitoring solution as the smoke detector. It's there. It's looking for anything obvious in the kitchen. It's there all the time, yeah? So it's there. It's looking for smoke. It's going to tell you whether there's a problem. NetBrain is there to say, well, actually, I'm going to dig deeper. So the monitoring solution, let's say my smoke detector, it goes off. There's a fire. It's coming from the kitchen. Don't know where it is, but there's a fire in the kitchen. So NetBrain will go, oh, hang on, let me check the toaster. Is it on? Is there any toast in the toaster? Let me check the grill. Do I have anything in the grill? No. What about the frying pan? Is the frying pan on? What about the oven? So it will go there and check everything to actually verify and dig deeper. Another analogy perhaps could be, you could almost think of your monitoring solution. This is a good one. You could think of your monitoring solution as a GP, or general practitioner, as a doctor. So it's there, it's looking for general problems. But actually, if you've got a heart problem, your GP isn't going to go and give you open heart surgery. He will refer you to a consultant, and he's a specialist in that area who can actually dig deeper to the underlying cause of the problem. So you'd think of your monitoring solution as your GP, and then NetBrain as your deep dive troubleshooting tool, your consultant. So I hope that answers the question.
Great analogies. All right, the next question is similar, like in terms of vendors. So what vendors does NetBrain support? Is it mainly Cisco, or do you support other network vendors such as Aruba and Fortinet?
Yeah, so again, our support is pretty good. Now, one of the things I need to find out here is, let me just check if I can actually post something on the chat to actually show you. So our support is actually very, very extensive. I mean, very extensive. I think last time I looked, actually, we supported about 300 different types of devices. So, I mean, really lots. And actually, the support is growing. And in fact, what I've seen before with customers where they've got some unusual, strange router or switch or whatever, they've come to us and said, oh, can you support this? And actually, as long as it's got a CLI, yeah, we can really. And we just say, look, can you show us the correct commands to give us the configuration file and different other tables, and show us the output from that? And the NetBrain will go away, we'll create a driver, and drivers are quick and easy to create, which are they're typically Python scripts. And then we can create support for that. And I will try and find our built-in multi-vendor support list now, and I will post that on the chat.
So you're saying it doesn't just have to be Catalyst switches?
No, we support pretty much anything. I'll put this under announcements. Perfect. There we go. Display announcement. That's our multi-vendor support list. We've actually got two. We've got another one for software defined. So the other thing as well is, again, I think you saw this in the demo. It's as well as having support for your traditional networking equipment, we also support software-defined stuff, SD-WAN, software-defined networking like Cisco ACI, but also the public cloud.
Yep, great. And how easy is it to actually add support for new devices, like upgrades?
Yeah, dead easy. So it's we have something called a multi-vendor support form, and it really is. Please enter the commands for configuration file, to how to retrieve the configuration file, the routing table, the MAC address table if it's a switch. And basically, they just send it to NetBrain. And we have drivers for all sorts of devices. And in fact, the list just keeps growing. So it's very, very easy, typically 2 weeks. So we had a customer, they had Lenovo switches, which I didn't even know Lenovo made switches. And that was fine. We had a driver for those within a couple of weeks of them asking for it. So very quick, really.
Another question here. Can we compare the primary and secondary firewall?
Yes, we can. So again, that's actually a really good question. So one of the things NetBrain can do is, I mean, there's a few things here actually, is we can compare devices and the network intent. So one of the things you could do is, and I could have even demoed this. So my colleague Leslie's got this wonderful network intent, which is set up in the UK demo environment, where we're comparing the active firewall and the standby firewall. So it's looking for things like, are the ACLs consistent? Are the policies consistent? And actually, is the active one the one we expect it to be? So very much, because it's all about issuing a command and then comparing commands for maybe the same device or different devices. So yes, very much so. I should have probably just said yes, because it would have been quicker, but yes.
Next question, is there a test environment I can try out?
Yes, so I'm gonna stop displaying this. Hopefully you've got that support list, and I want to show you this. This is actually very good. So if you look at what I showed you, so there you go. I'll put it on the announcement. So if you look at what I showed you for the demo, that's our main internal lab, which we use for things like demos for customers and also for webinars. We've also got, as I've posted here, the test drive, NetBrain test drive. So that's a similar environment, which is it's useful for people who want to learn about NetBrain. Just to give you a taste. And so it's quite good because it's got its own networking devices in there in the cloud, and it's got NetBrain in there. So it enables you to actually go in there and have a play. So actually it's funny because we use it for new recruits to NetBrain, USEs who want to come in NetBrain. We just give them that link and say, learn it, and then demo it to us. But it's also got some guides as well, which is really nice. So you're not just left to your own devices. You can actually get some guidance as well.
And the last question I'm seeing here, Dave, is you showed that the probe triggering and network intent. Is there a way to configure an external trigger to do the same thing?
Yeah, that's really good. So there's a number of ways of doing that. So you could do that via something like ServiceNow. So ServiceNow is probably the easiest because we've got built-in support. There's even a NetBrain app within ServiceNow. So when somebody raises a ticket, you can configure it so that based on certain triggers, keywords, things like that, it will actually talk to NetBrain and say, NetBrain, map a path. NetBrain, show me this area, and then NetBrain trigger and run these particular network intents as well. So very much, and we call that triggered automation. And from a ticketing point of view, you're basically making NetBrain your first level support guy, because NetBrain is going there right at the time the ticket is raised, and it's performing some diagnostics. But you can also do it with things like your monitoring solutions. So like I said, somebody asked about how we fit in with monitoring solutions. Yeah, your monitoring solution, maybe your monitoring solutions detected something. Maybe one of your applications is suddenly running really slowly. Well, it can trigger NetBrain. So it can talk to NetBrain and say, oi, NetBrain, map a path for this particular application. It can actually pass parameters in the API call to NetBrain. So they're probably the two ways you do that.
Great. So I think, there's plenty of resources here on the website to get started, including the test drives. So great to have you guys here joining us today. And hopefully you can go and do that or talk to Dave offline. Thank you so much again.
Thanks, everyone.